Lesson 16, relating scale drawings to ratios and rates. Students understand that a scale drawing is either the reduction or enlargement of a two-dimensional picture. Students compare the scale drawing picture with the original picture and determine if the scale drawing is a reduction or enlargement. Students match points and figures in one picture with points and figures in another picture. So basically, if we have a shape and it's a reduction, that means it's made smaller. An enlargement means bigger. Celeste drew an outline of a building for a diagram she was making and then drew a second one mimicking her original drawing. State the coordinates of the vertices and fill in the table. So our vertices for here, I'll label them A, B, C, and D. And I'll label this E, F. Oh, can't even. E, F, G, and H. So A is over 0 up 7. B, no, I'm sorry. A is over 7 up 0. B is over 7 up 18. C is over 13 up 18. And D is over 13 up 0. So now the corresponding points that go with that, E, F, G, and H. So E is over 7 up 0. F is over 7 up 9. G is over 10 up 9. And H is over 10 up 0. So those are the coordinate points. So now we need to take the height and the length of the original drawing. So the height goes from 0 to 18, so it's 18 high, and from here to here, so it goes from 7 to 13, so that's 6 long. The smaller one, the reduction, so this is a reduction because it's made smaller. The height goes from 0 to 9, so it's 9 high, and goes from 7 to 10, so it's 3 long. So now to figure out the rate of the reduction, we're going to take the new drawing over the old drawing. So this is the new over the old. So the old is also the original. So we're going to have the new drawing is 9, the original drawing is 18. So this is 1/2. And the length is 3 over 6, which also works out to be 1/2, or 0.5. So that's our K, kind of. Now it's going to turn into R, meaning scale factor. Luca drew and cut out a small right triangle for a mosaic piece he was creating for art class. His mother really took a liking and asked if he could create her a larger one for their living room. and Luca made a second template for his pieces. So here are his two, and he needed to make a bigger one. So this is the original, and this is the new one. Does a constant of proportionality exist? If so, what is it? So we can take a look at the height and the length. So the height is going to be the new over the original. So that will be the original is 5 high, and the new one is 15, giving us a scale factor of 3. Now the length the length of the original, so this is 5, and then that's 3. Lengths of the second are 15 and 10. So if I take, this is my x and this is my y divided by x, I get a scale factor of 3. Oh wait, that can't be 10. Is it? Yes, it goes from 5 to 15, which is 10, and 5, 6, 7, 8. So that's only 3. And if I divide this, 10 divided by 3 is 3 1/3. So is Luca's enlarged mosaic a scale drawing of the first one? No. For it to be a scale drawing, he has to have the same scale factor for all the dimensions. No. To be a scale drawing, the scale factor must be the same for all the dimensions. Look at that, I'm going back and fixing it. Got to put a capital there. Oops, no comma. Use the graph provided to decide if the rectangular cakes are a scale drawing of each other. So I'm going to do cake 1. I'm going to do it in blue. Oops. Haha. So cake 1, I'll do it in blue. So I go over 5, up 1, 2, 3. Over 5, up 5. Over to 11, up to 3. And over to 11, up to 5. So here's the blue one. So that's 1, 2 high, and 1, 2, 3, 4, 5, 6 long. The other one I'll do in red. So over 1, up 6. Over 1, up 12. Over 13, up 12. And over 13, up to 6. So this is 1, 2, 3, 4, 5, 6. So it's 6 high, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is 12. So I'm going to call this one the original, and this one the new. So if I take the original, is the blue one, so 2 over 6 equals 1/3. And then if I do 6 over 12 is equal to 1/2. So no, because the scale factor isn't the same for both dimensions.